Hello and welcome to today's lesson on the particle motion in gases, which is found in the particle model of matter topic in GCSE Combined Science Physics. So in today's lesson we're going to try to understand particle motion in gases. So if we're successful and we learn in today's lesson, we should be able to describe the motion of gas particles, describe the temperature and pressure of a gas change with each other, and understand temperature and pressure in terms of the particle model. So we're going to look at the following part of the GCSE Combined Science specification, particle motion in gases. So to understand gas pressure, you must be able to describe what the particle models of gases are. So in the particle model of matter, gas can freely move, so that means they can move randomly in all directions and they have a variety of speeds. So gas particles, because they are freely moving, means they have a high kinetic energy store, whilst because the gas particles are far apart, they have low forces of attraction, so the gases contain a low amount of potential energy. So what this means is that gases have an internal energy which is mostly comprised of kinetic energy and very little potential energy. So to clarify, the molecules of a gas are in constant random motion, so they move in random straight line directions with a variety of speeds. So to understand about gas particles and gas pressure, we've got to consider the properties of a gas. So what properties does a gas have and what properties can we measure? Now there are three main properties of a gas which can be measured: the volume of a gas, the temperature of a gas, and the pressure of a gas. Now in reality, a gas is comprised of billions and billions of particles. However, in this example, to simplify everything, we're just going to consider a gas to be one particle in a box. Now when we consider placing a gas particle in a box, we say the gas is in a closed system because the gas cannot escape. Now just to clarify, gases follow different laws in closed and open systems. Now in this course we're only going to consider gases which are trapped in a space, i.e. a closed system. Now the first property we're going to look at for a gas in a closed system is the volume. Now the volume is the space occupied by the particles that make up the gas. So in the previous example, it's the space of the box. Now note, the volume of a gas is the space between the particles. It's the space that a gas can fill. It is not the volume of the gas particles themselves. So it's important to know that the volume of a gas is much larger than the volume of the gas particles that make it up, as shown in this particular diagram here. Now the next thing to look at is temperature. Now temperature is a measure of the average kinetic energy of the particle. So it links to the average speed of the particles. So to clarify, temperature is linked to the speed of the gas particles. So what this means is it's related to the average kinetic energy of the particles in a gas. So the higher the temperature, the faster the gas particles move on average. The lower the temperature, the slower the gas particles move on average. Now you must state that kinetic energy and speed is an average in this case because gas motion is random. Now work can be done on a gas, which means to place energy into the gas. So an example of this would be to pump up a gas in an enclosed volume. Another example would be to blow up a balloon. Now, and this is important ideas because if the energy is being given to the gas, then the internal energy of the gas is increasing. So as most of the internal energy of the gas is the kinetic energy store, this means the temperature of the gas increases. Now the third property we've got to consider is pressure. Now when a gas particle collides with the walls of its box, the walls of its container, it exerts a pressure on the box. Now this pressure is always exerted outwards as the particle is always collide with the inside of the container. Now it's better to say that when the particle collides, it exerts a force on the side of the container which leads to a pressure. Now to clarify, when it hits the container, it produces a force at right angles to the container which is always exerted outwards from the container it is in. Now a force is produced by a gas particle when it collides with the side of the container because when it does so, it changes momentum. So to clarify what we've learned so far, the gases have three properties. Property 1, the temperature of the gas, a measure of how fast the gas particles move, and it's related to the average kinetic energy of the gas particles. Property 2, volume, a measure of the space which the gas particles can move into. And property 3, pressure, a measure of the force exerted at right angles to the container or surface when the gas particles collide with the container or surface. Now, there's a law that links these properties together in a closed system, and this is called Boyles Law. Now, Boyles Law considers how the pressure and volume are related under a constant temperature. Now, if the temperature is constant, this means our gas particles are moving at a fixed constant speed. So if we increase the size of the box, we make the volume bigger, it means there are fewer collisions in the same time because the gas particles have to travel further before they collide with the side of the box. So the bigger the box, the fewer the collisions, as the particles have to travel at the same speed to hit the side. So what this tells us is increasing the volume decreases the pressure of a gas, and the other way round, if we make the box smaller, the particle will collide with the box more often since it has a smaller distance to travel. So smaller box, more collisions, as the particles have to travel a shorter distance at the same speed to hit the side. So decreasing the volume increases the pressure of a gas. Now remember, if you have a high pressure, that can cause a container to explode or to break. So it's important to note that as the pressure increases, the volume decreases. So the pressure and volume are inversely proportional to each other. So this is our example of Boyles Law. So when the temperature is kept constant, the volume and pressure of a gas are inversely proportional. Increasing the volume decreases the pressure as the particles collide less times with the container every second as they have further to travel. Now we can also consider using the particle model what takes place when the volume is kept constant. If the volume is kept constant, it means that the box that the particles are contained in has a fixed size. Now we can use a particle model to find the relationship between the temperature of a gas and the pressure the gas exerts. So if we increase the temperature, we increase the average speed of the particles in the gas. So because they're moving faster at a higher speed, the particles will hit the side of the box more often, so moving faster gives more collisions, and more collisions increases the pressure of the gas. Now once again, remember, high pressure can cause the container to explode or break. So if you slow the molecules down, you decrease the temperature, the particles will hit the sides less often. So moving slower gives less collisions. Less collisions gives a lower pressure exerted by the gas. So this tells us as temperature increases, pressure increases. As pressure decreases, temperature decreases. So we have a relationship in direct proportion. But that's only one reason why we see this relationship. Because as well as when you move faster, you will hit the side more times, you'll also hit the side with a greater force. So moving faster gives the collisions a greater force as the particles hit the side of the container. Now more forceful collisions gives a greater pressure. Now again, remember, a high pressure can cause the container to explode or break, whilst moving slower gives collisions with a smaller force. So what this means is if the temperature decreases, not only do the number of collisions every second go down, but the force with which the collisions take place also goes down. So like we said before, as temperature increases, pressure decreases. As pressure increases, temperature decreases. So this relationship is in direct proportion. So there are two reasons to why this relationship is observed. So because these two values are in direct proportion, what this means is if we plot pressure against temperature, we get a straight line through the origin for our graph, because that is how direct proportionality is shown, which you can look at with the following animation. So, in a closed system, the gas follows the following laws. The temperature-pressure law. When the volume is kept constant, the temperature and pressure are directly proportional. Increasing the temperature increases the pressure as there are more collisions per second with the container and more forceful collisions per second with the container. So, if we have learned in today's lesson, we should be able to know the following ideas. Molecules of a gas are in constant random motion, and the temperature of a gas is related to the average kinetic energy of the molecules. Changing the temperature of a gas held at a constant volume changes the pressure exerted by the gas, and you should be able to explain how the motion of the molecules in the gas is related to its temperature and its pressure, and explain qualitatively the relationship between the temperature of a gas and its pressure at a constant volume. And a gas can be compressed or expanded by pressure changes. The pressure produces a net force at right angles to the wall of the gas container, So you should be able to use a particle model to explain how increasing the volume in which a gas is contained at constant temperature can lead to a decrease in pressure. So if we've been successful and we've learned in today's lesson, we'll be able to describe the motion of gas particles, describe the temperature and pressure of a gas change with each other, and understand temperature and pressure in terms of the particle model. I hope you've enjoyed today's lesson looking at the particle motion in gases in the particle model of matter topic in GCSE Combined Science Physics. Thank you very much for listening to this lesson and have a lovely day.